So today I'm going to be doing a lesson over acid-base balance and how it pertains to being a paramedic. A couple of things to take away from this lesson is what acid-base balance is, how it is maintained, what the imbalances of it are, what causes the imbalance, what a normal reading of an ABG is, what an ABG is, why capnography is used and why it's important, then how to identify the imbalances and how to treat the imbalances. So starting off, acid-base balance is essentially the maintenance of bicarbonate and hydrogen ions in the body. So, you eat food, your cells take in the food as lipids fats, whatever you want to call it, lipids or fats, same thing, and glucose to create a byproduct after metabolizing it, H2O and CO2, so water and carbon dioxide. The water and carbon dioxide go under a chemical reaction to form carbonic acid, and then the carbonic acid goes under another chemical reaction separating to bicarbonate and hydrogen ions, which are transported through the blood via the hemoglobin to the lungs and the kidneys, and wherever else blood goes. But anyways, so whenever a body has too much bicarbonate, hydrogen, or CO2, it's considered an imbalance. And too much hydrogen or CO2, the body will become acidic, and if there is too much or too little too much bicarbonate or too little hydrogen or CO2, it will become alkalotic. So next, we're going to start off on how the balance is maintained in the body. So the first initial, most immediate control of the imbalance is the buffer system. So as I mentioned earlier, your cells create CO2 and water from metabolization. They split up, or they don't split up. They get together to form carbonic acid and then split back up into hydrogen and bicarbonate. And whenever it does that, that's kind of essentially the buffer system. And what it does is it absorbs whenever there is an excess of hydrogen ions or bicarbonate. So it absorbs it into this equation. So you have your water, your CO2, it forms to create carbonic acid, which then splits up into hydrogen and bicarbonate, and it moves to the left or to the right depending on what it absorbs. And it works along with the other two ways the body maintains it, but a lot of it has to do with the respiratory system. So, like I said, it works alongside with the buffer system. And after the carbon dioxide and water is created, it goes into the chemical buffer system and combines and then splits back up, is transported to the lungs, and after in the lungs it combines back together to form carbonic acid and then splits back up into water and carbon dioxide. After the split, which happens, like I said, in the lungs then breathe off all of the extra carbon dioxide, and they take in the O2 to be sent back to all the cells and everything. So you breathe in, take in O2, you breathe out, and you breathe off the carbon dioxide. And the third way is kidneys. The kidneys play a very, very vital role in acid-base balance. They filter all the blood and filter out all the toxins and stuff in the blood, but they excrete the excess hydrogen ions, excess bicarbonate, and excess water, while also simultaneously producing bicarbonate when needed. If the body's too acidic, it will create more bicarbonate to counteract and have more of the chemical equations from the buffer system. So it'll create more bicarbonate to absorb the hydrogens and so on. But it acts as more of a long-term balance than an immediate. So next we're going to move on to the imbalances in the body. The body has 4 types of imbalances when there's either a respiratory imbalance or a metabolic imbalance. Respiratory is caused by either too little or too much CO2, and a metabolic imbalance is caused by too much or too little of bicarbonate or hydrogen. So respiratory acidosis is the first one. It is caused whenever there is an increase in CO2, which the increase in CO2 is caused by many different breathing problems, with some examples being, drug overdoses, which is going to depress the CNS, causing you to breathe slower or not at all. Any CNS depressants, cardiac arrest, you're not breathing at all, you're retaining all of the CO2 created. And then like COPD, asthma, shallow breathing, anything that is just causing you to not breathe off all the excess CO2 and you retain it all. So any breathing problem, whether there's air trapping and so on. But next we have respiratory alkalosis, which is caused by a decrease in CO2, which mainly, it can be caused by many things, but mainly hyperventilation, like somebody's having a panic attack, so they're breathing really fast and they're breathing off more CO2 than what the body can actually create. And then third, we have metabolic acidosis, which is caused by an increase in hydrogen or a decrease in bicarbonate, and which those two are caused by any metabolic issues or kidney issues. Some examples of these issues would be like DKA, sepsis, which is a lactic acid buildup, hyperkalemia, which is high potassium, or some tricyclic antidepressant overdoses. And then moving on to the fourth and final imbalance is metabolic alkalosis, which is caused by a decrease in hydrogen ions or an increase in bicarbonate. It is pretty rare, but we should still know the signs and the symptoms of it, or what causes it, which it's normally caused by massive vomiting. So you're throwing up all your stomach acid, vomiting it all out, except diarrhea for longer than just an hour. But same principle applies to diarrhea as it does to vomiting. And then like a significant ingestion of alkalizing agents, so any antacids, Tums, Pepto, stuff like that, anything that's going to absorb acids. And then you also have hypokalemia and hypovolemia too, which can cause the alkalosis. So next we're going to move on how to diagnose and treat these things, which one way to do it is through an ABG, but as a paramedic on a truck, we don't normally have those. I know some flight medics and nurses, they'll have access to immediate laboratory testing, kind of like a blood finger stick glucose reading, but it's an ABG reading on the helicopter. But having a basic understanding of what ABG is really can help and kind of help you figure out what's causing it and what happens in the body. So an ABG is an arterial blood gas, so they'll take a big old needle, stick it into an artery, draw up some blood, and then they'll read the blood, and they'll read the blood for its pH, bicarbonate, and carbon dioxide. So we'll move down here and use a little picture a little easier. So if you took science class in high school, which everybody should have, you know that the pH scale is between 0 and 14, with 7 being in the middle as a neutral. So the body is fairly neutral. It's between 7.35 and 7.45. Has to maintain that very small window, or it becomes either acidotic or alkalotic. The higher the number, the more alkalotic you are, and the lower the number, the more acidic you are. And then for the CO2, or the partial pressure CO2, if you are above 45, then you are considered acidic, and if you are below 35, you are alkalotic. And then the third thing it measures is the bicarbonate, which if you have less than 22, you are considered to be acidic, and if you're above 26, you're considered to be alkalotic. And then here we have kind of example of how to read an ABG. Really, like I said, it's not so much important to us unless you're working in a hospital, which then I would recommend learning how to read it a little bit more. But we're just going to say the blood pH is below 7.35, which means you're you're in acidosis. So then you would look at the next two, your bicarbonate or your CO2. If your CO2 is greater than 45, you are in respiratory acidosis. And then if your bicarbonate is less than 22, you are metabolic acidosis, which the metabolic acidosis is your body compensates by respiratory compensation. And then for respiratory acidosis, you'll have like a renal compensation to try to get rid of it. Like I said, the filters the blood, and once it will take out any excess of anything. And then the same principles kind of apply for alkalosis, but just a little bit backwards. So since we don't have access to the ABGs, we use capnography, in which capnography is used for several things in EMS, but today we'll really focus on how it pertains to acid-base balances. So for the same parameters as an ABG, apply to capnography, except for it measures the CO2 from exhaled gas instead of arterial blood. So the same thing, if the reading is below 35, they're considered to be alkalotic, and if their reading is above 45, they're considered to be acidic. And it's used to diagnose pretty much all of the imbalances. One thing that I will say about capnography is in DKA patients and sepsis patients, they will show a decrease in CO2 instead of an increase, even though those are both acid induced imbalances. So you can kind of come over here for DKA, which is both of them are metabolic acidosis. You compensate for with the respiratory system to help try to breathe it off, all the extra acids, and so on. That's why you have a lower reading, which is normally below 25, would indicate DKA and sepsis. But you kind of have to get a really good patient history on what's going on, and all your other vitals will help you determine that. And then here's an example of what a capnography reading should look like. You start out at the A point here, which is breathing in, and then that measures you breathing out, and then as soon as it drops back down, that's you breathing in, your pause, breathing out, and then so on. So based on capnography, we'll move to identifying the imbalances. So this pretty much for all of them, you want to get how the patient presents, get a good set of vitals, find out what their baseline is, gather a good history on all of these people, and then always use capnography. And for respiratory acidosis, you're going to, like I said, use capnography. Patients will present normally with like headaches, anxiety, restlessness, trouble breathing, blurred vision, so on. For your respiratory alkalosis, the patients will present with dizziness, bloating, lightheadedness, carpopedal spasms, chest discomfort, irritability, and sometimes numbness to the face and extremities. And then the third thing, metabolic acidosis, is the patients will present with the nausea, the vomiting, and general weakness. And a lot of times the capnography will show a compensatory respiratory alkalosis. And then metabolic alkalosis, same thing, only I haven't found anything to where we can use capnography that will show the alkalosis. It is pretty rare. You're only going to have an ABG to find it out, but I mean, you can pretty much rule out everything else beforehand. But you really kind of have to mainly rely on history and other vitals. The patients will be very lethargic, have tensiony, chest pain, shallow breathing, and sometimes seizures. So here's some pictures I found that really helped me learn it, kind of have the body and what happens. So you have your increase in partial pressure CO2, which causes your pH to decrease. You're retaining all the CO2. You have rapid shallow respirations. Your blood pressure is going to drop. You'll maybe either hypoventilating. You'll have cyanotics, impale skin, headache, high potassium. High potassium can cause dysrhythmias, be drowsy, dizzy, a little disoriented, muscle weakness, hyperflexia, and some of the causes are respiratory depression, anesthesia, overdose, increase in intracranial pressure (ICP), any like airway obstructions, al- alveolar capillary diffusion like pneumonia, COPD, RDS, PE, so on. Then for like respiratory alkalosis, they'll present with seizures. They'll have rapid breathing. So they're breathing off all the CO2. So their CO2 is decreasing. Their pH is going up. They'll be tachycardic. They'll normally have a little bit low or normal blood pressure. They'll be hypokalemic. The patient might not present with every single thing, but if they present with multiple, if it walks like a duck, it quacks like a duck, it's probably a duck. Numbness, tingling of the extremities. They'll, like I said, be lethargic, maybe a little confused, have a little bit of a headache, nauseous, vomiting, hyperventilating, anxiety. Some PEs can come off this way, and then like fear, causing you, to breathe a little faster. So metabolic acidosis, they'll present with headache, blood pressure will drop, be hyperkalemic, muscle twitching, so the whole body is going to be kind of shaking, whatever. Warm, flushed skin, so they'll have vasodilation, can't really see that word. Then they'll be nauseous, vomiting, muscle tone will kind of decrease, reflexes will decrease. Kussmaul respirations, which is the compensatory hyperventilation. See that a lot with DKA patients. They're trying to breathe off all that excess CO2 even though they're really not. So causes would be increase in hydrogen production, which is from the DKA or hypermetabolism. Renal failure, so you don't pee or excrete all of the excess hydrogen. A decrease in, like, same thing with renal failure. You kind of have a decrease in bicarbonate function, or maybe you have an increase in eliminating the bicarbonate. So you have an increase in bicarbonate and you have trouble eliminating it, and that would be like diarrhea, stuff like that. Then metabolic alkalosis. So you're normally going to have an increase in bicarbonate or a decrease in acid, or both. They're going to be confused. We'll have some dysrhythmias, compensatory hypoventilation, so they'll be breathing real slow, trying to retain the CO2 to make their pH go up. So like I said, antacids, maybe they gave too much sodium bicarb, or a decrease in hydrogen, so that's sucking out nasogastric suction, so they're sucking out their stomach acid or just their stomach, but it ends up sucking the acid out, and then they'll have like prolonged vomiting will cause it, and they'll present with more dizziness, increase in irritability, more nausea, vomiting, and diarrhea. They'll probably have some anxieties or even some seizures from it, but they'll have the tremors, muscle cramps, and tingling of the fingers and toes. So moving on to how to treat these imbalances. So for respiratory acidosis, you should be treating all of these at the source if possible. Always try to fix that if you are able. If not, then treat the symptoms. But for respiratory acidosis, you can assist with the airway with like bronchodilators, CPAP, BVMs, supplementary oxygen, or in some worst case scenarios, intubation. Respiratory alkalosis is the same thing, treated at the source, and then give oxygen if needed, and if they have anxiety, coach them on their breathing, have them breathe with you, slow them down, cause them to retain all the oxygen before they pass out, or not the oxygen, the CO2 before they pass out. For metabolic acidosis, same thing, treat at the source. And some of these severe patients, maybe they overdose on the tricyclic antidepressants, sodium bicarb to help absorb all the hydrogen, aid in buffing. And then like DKA and sepsis, treat with large amounts of fluid to help dilute all the hydrogen, dilute their blood, so kind of neutralizes them out a little bit. And then metabolic alkalosis, the same thing, treated at the source and should be treated with large amounts of fluid also. So that is the end of my lesson. Is there any questions? No, no questions. Moving on. We now have a check for understanding. So y'all have to write this on a piece of paper, turn it in at the end by tomorrow. What it is, post it on Canvas, whatever. Get it to me, get it wrote down, and we will call it good.